Hey guys, and welcome back to a new video. Properly reading files from external storage in Android is complex as hell. And I feel like there is no other thing that is so restricted as external storage on Android. And with every new Android version that comes out, new restrictions also come out. So in today's video, I want to help you out if you need to read some sort of external files, specifically media files like images, audio files, and videos, to be able to read these on the latest API levels as well as down to API level 26. So this is the little sample app we will create here, just a simple lazy column, a list that lists all of our media files we currently have on our file system in external storage, so audio files, image files, and video files. I want to say right away, if you just need the user to pick a specific file on their file system, a specific image, for example, to display in your app, then you don't need all that hassle we will implement here. Since then, you can just use a so-called activity result launcher, which will give you a content URI, so just an address kind of to that file, which grants you temporary access to read that file. So if you just need access on a few select images, a few select videos that you let the user pick, then what we will implement here is not needed. But if you really need that full access on all images, on all videos, and all audio files, or one of these at least, then you will have to follow here. All right, so I am here just in a blank Android Studio project, and the first thing I want to create here in our app, content Java, blah, 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 is an enum class that helps us to distinguish between different file types. So we will have a media type enum class here, which can be either an image, a video, or an audio file. And with this media type, we can then also construct another data class that corresponds to one media item. So just one element we want to show in our list, which would be a media file, data class. Each media file will have a specific URI, so an identifier, something we can use to locate that file. It will have a file name, and it will have a type, which is of type media type. And what we can then do is we can create something like a media reader or so, which I will just make a normal class here that will take an instance of our context, since it needs to talk to an API called media store. So you can think of media store just like a giant database that stores metadata for any type of media items. So metadata might be the file name, it might be the file type, it might be the file size, it might be the specific type of file we're dealing with, it might be the URI we can then use to read that file. So media store doesn't really save the files itself, those of course located in our file system, but it contains all the relevant metadata that is stored together with a file. And the technical term of something like that is called a content provider, since media store is just a big pool of data that provides content for us. And if we want to get that content, for example, get media files, let's call it get all media files to be more explicit, which will then return a list of these media files, so our own custom data class. We will have a list of media files here, so that's already perfectly suggested, so just a mutable list. We will then later on add all our queried media items. And the way this works to query these items from media store, from our big database, is we need access to content resolver, which we get with our context, so context.content resolver, and then we can call query. That is quite a big function. So on the one hand, we need to pass a specific URI, so the actual file location we want to query. We need a projection, we need a selection arguments, and a sort order. So the last four are actually optional, but these allow us these typical database-like operations, like selecting certain columns we only care about, like filtering out specific items or specific media files that match a certain query, and optionally also sorting these based on a specific attribute. So let's do this one step at a time. First of all, let's come up with our query URI, because retrieving that depends on our current API level. So we can check that if build version SDKInt is at least 29, and then we can retrieve that query URI with media store dot files, since we want to query files obviously, that get content URI. And the volume name is media store dot files dot, actually not files, but just volume external. So we query our external storage. This constant here is only available from API level 29 onwards, but if we look into that, it's really nothing else than this external string. So we can also use that on API levels below 29 and it will work just fine. So else we will just say media store files get content URI, and we type in external on our own. Another thing we need is our projection. So basically the columns from our queried database items that we care about. So as I said, there's so much different types of metadata we could query here, but we only care about the ID of each media file. We care about the name and the type. So we can have the projection, which is nothing else than an array of something. And here we can specify that with media store files, file columns, so the columns in our media store database. And first of all, we want to care about the ID of each item. We want to care about the display name, so the file name, and want to care about the MIME type, so the actual file type, which you can then use to decide, okay, that's an audio file, that's a video, that's an image. And other than that, we don't need anything else in order to manipulate our query. So we can just pass in our query URI for the projection. We can pass in the projection. Selection is null, since we don't want to select specific values, but just get all values that the query covers. We don't want any selection arguments, and we also don't want a specific sort order. Then what we can do is we can call that use, since this query function, if we take a look, will return a cursor. So cursor is something you very typically get when getting a database result. And that now allows us to pretty much loop over every single row that is contained in that result and let us map that to whatever we want. In our case, to our media files that we have our list here of, in order to then add these to our media files list and return that finally. So here in this use block, we get this cursor, which will, by the way, automatically be closed since we use use. And first of all, we need references to each single column we now want to read. So on the one hand, that is the ID column, which we can get with cursor.get. Actually, let's use a null check here. So we make sure to get a non-nullable cursor, and then we can also have a null safe access here. So cursor.get column index or throw. So it throws an exception if that does not exist. And we say, okay, this one will be media store.files, file columns ID. So we just enter the name of the column that we expect here, and we will then get an integer, which we can then later on use to read something at that specific column. Then we can copy paste this here 2 more times. We do have a name column, which will read in the display name, and we do have the type, or let's call it MIME type column, where we read in the MIME type. Now we have references to each column, so the actual column index. What we want to do next is we want to have a while loop while the cursor dot move to next. So while there is a next row to loop over, we want to execute this code and construct a media item out of every single row that was contained in that query. So we can get the ID, as you can already see here, by saying cursor.getLong. Cursor get long, since the ID field is of type long. We pass in our ID column index here. We can then do the same for the name, cursor.getString in this case, for our name column. And we do have our MIME type. So cursor getString and pass in our MIME type column. Now it can sometimes happen that the name and the MIME type is actually null here, since this query might also involve certain system files, so files that aren't strictly media files, and we want to filter these, but we can quickly do that by just adding a null check. So if the name is not null and the MIME type is also not null, only then we want to construct our media file item and add that to our list. The ID will always be non-null here. So here, in and of itself, we could just say media files.add. We construct a media file, but we will quickly notice that we're still missing the URI of that file. So the actual address where we can read this file if we need this in the app. The name we can already assign. And the type, well, we could say that we pass in our MIME type, but the MIME type is not the same as our media type. So the MIME type might be something like audio/MP3. But in the end, we just care about if it's an audio file, a video file, or an image file in our use case. So we need a bit more code before. On the one hand, we want to get the content URI, the actual URI where we can read this file. So content URIs dot with appended ID, which is the query URI, and we append the ID, so the specific ID of this file item. And by appending these two, so the actual starting path kind of, and the ID, we get the final content URI, which you could then later use to read the contents of this file. And what we need is we need the media type, where we can say when, so when our MIME type actually starts with audio / then we know that we're dealing with a media type dot audio. If the MIME type starts with video / then we know we are dealing with a video. And in all other cases, we're dealing with an image type. And then we can also pass the media type down here. We can pass our content here to our media file. And after this big use block, we can then finally return our list. So return media files.toList. So we just convert this mutable list to a read-only list again. All right, I wish I could tell you that this is it. No, it's not, because we still have to care about all those permission-related things. Since on different API levels, reading files from external storage requires different permissions. Welcome to Android. So let's get started to understand how these permissions work. Of course, we need to put that in our manifest, and I can already tell you there are a lot of permissions. So originally, we just needed this read external storage permission in order to get full access on the user's external storage and read all such media files. You will notice that we already get a warning here. If we hover over this, you can see it's deprecated when we target at least Android 13, which we are. And it says that nowadays we actually need access to these newer storage permissions. So read media images, read media video, and read media audio. So starting from Android 13, Android started to introduce these more fine-grained permissions so that if your app only needs to read images, then you only need to request permission to read images, but then your app also only can read these images from your media files. And therefore, if we need all of these file types and read these into a single list, then we also need to request and grant all these three permissions. So instead, we will have read media audio, read media video, and read media images. However, you will notice that we get another warning that our app is currently not handling selected photo access introduced in Android 14. So you can notice how much of a pain that is to deal with external storage in Android. What is this selected photo access? So that's a new feature that was introduced in Android 14 that allows the users to not grant access to all their photos, but possibly only to some select photos they select. And right now, if we use these three permissions, we don't support that feature. So if the user only selects a few photos, which they definitely can, because that is contained in the permission request that the users asked, hey, do you want to grant access to all photos or just a select few? If they do that and they just grant access to a select few, right now we would not get permission to read any of them, even not those the user explicitly granted, because we're lacking another permission. Let's duplicate that and say we want to also have this read media visual user selected. And after adding that, we finally get rid of these warnings. So we need 4 permissions, which we not only need to put in here in the manifest, but which we also need to grant just to read the media files of our Android file system. And I'm not sure if we need this read external storage permission for devices running on API level less than 33, because it explicitly said it's deprecated. But we could also do something like this, that we have read external storage, and then we give this a max SDK version and set this to 32, because then we also get rid of the warning. So this would be for devices running on 32 or less, and this is for all other devices. So let's go to main activity and request these permissions. I will say right away that I won't implement proper permission handling here with showing a permission rationale, with handling the user declining this permission. This video is much more about, hey, this is what you need in order to properly show and load all these external media files. So in order to request permission, we can use activity compat, request permissions, pass in this for the activity, pass in an array of, which you probably also need to construct based on the API level. So permissions is equal to if build.version SDKInt is at least 33, then we need an array of manifest, permission, read media audio, read media video, and read media images. Here we don't need to put in the 4th permission, since that is not one that needs to be requested, but just needs to be a part of this permission set. But if we are not on that Android version, then we want to just request the manifest, manifest Android permission read external storage permission. And we can take this array, pass it in here to our request permissions, and the request code can be 0. We are not going to need this. So with this setup, we will get the permission request, we can grant it, but then we will have to relaunch the app in order to really see the files, since we did not implement any callback mechanism here to automatically read these files after granting permission, because proper permission handling is a topic for a complete dedicated video on its own, which I already have. So the last part of this video will be displaying all that in a lazy column. And for that, since we need to load certain images by their content URI, I would like to use the image loading library coil, which we need to add here to our version catalog. I will paste in the version that I will use. You can of course also copy paste this from the GitHub repository down below. And here under libraries, we can paste this coil kt compose. Let's actually just call it coil compose. We can sync this and then go to our build.gradle module app, scroll down to our dependencies, and down here, or let's put it up here, we can put implementation libs.coil. After that was fully syncing libs.coil.compose. We sync this and then we can easily display these images. Okay, so what we need is we need a little composable. So here in our root package, something like a media list item or so, make that a file, call that a composable function, media list item. And in here, we're going to take our file, so the media file. And if we recap that a little UI that we built here, then you can see there's really nothing else than a row of an image, so our async image we get from coil, and a text that shows the image's name and the file type. So to build this, we can just use a row. We give this row our passed in modifier. We can say that we have a vertical alignment of alignment center vertically. And for audio files, it's pretty hard to have a thumbnail, so I will just use a generic PNG file that I will paste here. Just like for videos, you could parse that would work, but for the sake of simplicity, I will also paste this simple video PNG file in here. So under project, in resources, drawable, I will just paste two files, so our audio file and our video file. Feel free to use any type of image you would like to use as the default here, but this is of course mainly about being able to display anything at all. So now, depending on the file type, so file.type, we can hit Alt-Enter to add the remaining branches. If it's an image, then we do want to show the real image, so we can say we have an async image from coil, where the model is the URI of that file, so file.uri, the actual image file, since that is easy to display. Content description, let's keep this null. Let's give this a modifier of modifier.width. Give this 100 dp of width. And for the other two cases, we can just use our normal image composable, since we just load an image from our resources in that case. So image that takes in a painter, where we can say, okay, that's a painter resource. And for video files, we say that's equal to r.drawable video. Content description is null. We just make sure to give this the same type of modifier with a width of 100 dp. And then we can copy paste this here for audio files as well, and just replace the image with audio. And everything that comes after this when statement, so after image, is really just a text that says on the one hand our file.name and then a dash with a file.type. We can give this a bit of padding to make this look a bit nicer, and also fill the remaining width by saying we have a weight of 1f. All right, going back to our main activity, I would like to create a little view model just to keep our state in there. That will really be a super simple view model. Just, a root package, call that main view model, which will take in an instance of our media reader, which we can also immediately initialize here. Oh no, we actually can't. We have to pass that in the view model in our main activity. Then this will be a normal Android X view model. And in here, we can then have a compose state for all of our files. We say by mutable state of, pass in a list, Alt-Enter to import that. And we need to make sure that this is a list of media files. So really just the list that will then be shown in our lazy column. Make this a private set, so only the view model can change it, and we can then call our media reader.get all media files. Here in our init function, we can then say that files is equal to whatever we read there. And also to avoid blocking the UI thread with this db read operation, since by default that would happen here, we can execute this in ViewModel scope in our IO dispatcher. Dispatchers.io, put this in there, and then it will be executed on a background thread. Then back in our main activity, we can have a private val here for our media reader by lazy. And in a real app, I would have some proper dependency injection set up, which I also have plenty of videos about. But here, I will really just initialize these values in main activity. So we have our media reader, pass in our application context to construct that. And we do have our ViewModel, which we can get with the by ViewModels delegate, which is a main ViewModel. And for the factory producer, we can now have a lambda function, which constructs a ViewModel factory, which initializes our ViewModel here. So ViewModel provider.factory. And in here, we hit Command O to override this create function, where we can create an instance of our main ViewModel with our media reader. We cast that as our generic type T. So this is really just something you have to do if you have a ViewModel with a constructor to properly bind this to your screen's lifecycle, so to the activity in this case. If you would be using Coin or Dagger Hilt here as a DI library, then you would not need to manually construct this factory. But since I did not want to overcomplicate this video with all these fancy libraries, let's do it like this here and initialize our ViewModel with a custom factory in main activity. All right, down here in our scaffold, we can then go ahead and have a lazy column where we pass in a modifier of modifier fill max size. We give it a padding of our inner padding. And then in here, we have a block of items. This one here that takes in a list of items, and we pass in our ViewModel files once they have been loaded. And in here, we can then say we have a media list item composable, and each file is just it. We can then also assign a modifier to make this fill the whole screen's width, fill max width, not parent width, but fill max width like that. And I think that should be everything. So I wouldn't bet that I didn't miss anything, but I would say let's try this out and see if I did. As I said, on the first try, we will first of all have to grant permission. Then we won't see anything because we will have to relaunch the app. But then on the second try, where we have permission and where we load these files here from our media reader, then everything should hopefully display just fine. All right, there we go. We do see our permission request. So the first one is for accessing music and audio files, which comes separately. If we click allow, we do get our new permission request. So here, if we actually require to access photos and videos both together, then Android will bundle this permission request. And you can also already see that we have three options where we can have either allow all access, so accessing all images and videos on the device. We can not allow that, of course, but we can also allow select photos and videos to be read by our app. Let's try this first. So I, of course, have a few sample files that I prepared here. Make sure to actually make actual photos with this emulator's camera and actual videos, because otherwise they might not be real media files. And same goes for audio files. If you want to try that out, I would recommend just really going to your emulator's Chrome browser and downloading some kind of sample MP3 file in that Chrome browser so that it's properly recognized as an audio file, as a media file, and that media store will also keep a reference to that file. So if we now say we only grant access to this image here with this back camera of the emulator and maybe this video and click allow, and then as I promised, nothing will happen. But if we now relaunch the app, then you can see that's exactly what should happen. So we do get the permission request again because Android tries to still get the full permission so that the user grants access to all images and videos. And as long as they only granted access to a select few, they will get this permission request until they declined twice. But in the background, you can already see that we do see our audio file, which I downloaded previously. So we granted permission for that. We do see our video, and we do see this single photo that we actually granted access to. If we now hit allow all, so we grant access to all media files, relaunch this, then we suddenly get access to all media files that we have on this device. And to also test this on a lower API level, let's also launch an emulator on API level 28, for example, where we don't have these new shiny permissions. There we go. I'm launching this here and it actually crashed. Let's take a look here in Logcat why that was the case. Not that one. So we do get a crash, permission denial, because the media provider Yuri requires read external storage permission. So it might be that we just need to add a permission check there. So let's allow this relaunch this and see if it at least reads the files properly. Yes, it does. So I only have a single image here, but it does read these files after regranted permission. Of course, it shouldn't crash at the very first try. So we should go to our media reader, and here we can have a check if is permission granted. Apparently that is only a thing on devices that don't support these fancy permissions like read media, video, images, and audio. So we might want to check for that. If the build.version SDK end is less than or equal to 32, from which version this becomes relevant, then we do add a check here with context compat, check self permission, pass in our context, pass in the permission we want to check for. So permission manifest.permission read external storage. And if that's equal to package manager permission granted, then we know we have that permission. And we might pick a bit of a better name here. I don't know, something like skip query, for example. So whether we should really skip the query or not, we should then also negate this, since if this is equal to or not equal to permission granted, only then we want to skip the query. In all other cases, we don't want to skip the query because it does not lead to a crash. So we can say if skip query is true, we return empty list. We then go to our emulator again, uninstall the app, this one here, and reinstall that. We should hopefully not get another crash. And yes, we do see our app's background. We do see the permission request. We hit allow, doesn't crash. And if we relaunch, then we should hopefully see our image. Yes, there it is. So I hope that wasn't too confusing. I'm also always a little bit overwhelmed with all these little changes, these little API level details, permissions. That is Android. That is what we have to live with if we decide for a native Android career. But I hope I could make your life a little bit easier with this video, because if I could, then you can probably also imagine how much easier your life as an Android developer will become if you get my more advanced Android premium courses. You will find the link down below in the description. Other than that, thanks so much for watching. I will see you back in the next one. Have an amazing rest of your week. Bye bye.